Have you ever stood before an ancient structure and wondered, how? How did they build this without the tools and technology we have today? The answers reveal an ingenuity so advanced, it borders on the impossible. Join us as we uncover 20 mind-blowing engineering secrets from the ancient world that still baffle experts. First, let's travel to the sands of Egypt. The Great Pyramid of Giza wasn't always the weathered, sand-colored giant we see today. Imagine it covered in brilliant white, highly polished limestone casing stones. These stones, cut with incredible precision, reflected the sun's rays with such intensity that the pyramid would have shone like a celestial beacon. It was said to be visible for miles, a radiant star on the desert horizon. Sadly, an earthquake in the 14th century loosened most of these stones, which were then repurposed for buildings in Cairo, leaving only the rugged core we know. Now to the heart of the Roman Empire. Roman concrete is legendary for its durability, but its most astonishing feature is its ability to heal itself. The secret ingredient? Volcanic ash. When tiny cracks form in the concrete and water seeps in, the ash triggers a chemical reaction. This reaction creates new mineral crystals that slowly fill the cracks, effectively repairing the structure from within. It's this self-healing property that has allowed monuments like the Pantheon to survive for nearly 2,000 years. Let's journey to Greece and gaze upon the Parthenon. The ancient Greeks were masters of perception. They knew that perfectly straight long lines can appear to sag or curve to the human eye from a distance. To counteract this optical illusion, they engineered the Parthenon's massive columns with a subtle bulge in the middle, a technique called entasis. This intentional imperfection makes the columns appear perfectly straight and uniform, creating a flawless visual harmony that was centuries ahead of its time. High in the Andes Mountains, we find Machu Picchu, the lost city of the Inca. Built on a precarious mountain ridge, it should have been washed away by landslides long ago. But the Inca were brilliant civil engineers. They constructed extensive agricultural terraces that served a dual purpose. These terraces not only created flat ground for farming, but more importantly, they stabilized the steep slopes and provided a sophisticated drainage system, protecting the city from erosion and collapse. In southern France, an aqueduct stands as a testament to Roman precision. The Pont du Gard, a three-tiered masterpiece, was built to carry water over 30 miles to the city of Enchimes. What's truly astounding is that this colossal structure was built without a single drop of mortar. Each massive stone block, some weighing up to 6 tons, was cut so perfectly that they fit together through friction and gravity alone. A 2,000-year-old aqueduct held together by pure geometry. Off the coast of a Greek island, a discovery was made that rewrote history. The Antikythera mechanism, an ancient analog computer, is a marvel of complex bronze gears. But just as impressive was its housing. The delicate, intricate mechanism was protected by a precisely crafted wooden case. This wasn't just a simple box. It was an integral part of the device, featuring inscriptions that served as a user manual. It showcases a level of mechanical engineering and protective design we once thought impossible for that era. In modern-day Lebanon lies Baalbek, home to some of the largest man-made stone blocks ever moved. The foundation of its Roman temple includes stones weighing over 800 tons. To put that in perspective, that's the weight of about 3 Boeing 747 airplanes. How ancient engineers quarried, transported, and lifted these megalithic stones with such precision remains one of history's greatest mysteries. Even with our most advanced cranes today, replicating this feat would be an immense challenge. Deep in the Cambodian jungle, we find Angkor Wat, the largest religious monument on Earth. It was built on soft, unstable ground in a region with heavy monsoons. To prevent the massive temple complex from sinking into the mud, Khmer engineers built it on a brilliant foundation. The entire site rests on a network of sand and water. This ingenious system acts like a hydraulic stabilizer, managing the water table and ensuring the ground remains firm, allowing the temple to essentially float on its foundation. Back in Egypt, consider the obelisks. These towering monuments, carved from a single piece of massive granite, were engineering triumphs. The process began in the quarry, where workers painstakingly separated the giant pillar from the bedrock without cracking it. Then came the monumental task of transporting it for miles, often by barge down the Nile, and finally, erecting it upright, a process so perilous that one wrong move would shatter a masterpiece years in the making. The Inca Empire, situated along the earthquake-prone Andes, developed a unique architectural style to withstand the tremors. Their walls are famous for their mortarless construction, where stones are cut so precisely that not even a razor blade can fit between them. These irregular interlocking stones allow the walls to dance during an earthquake, shifting and settling back into place without collapsing. It's a form of seismic resistance that has allowed these structures to outlast many modern buildings. In the desert canyons of Jordan, the city of Petra was literally carved into the rock. But its creation was only possible through masterful water engineering. The Nabateans, who built the city, controlled the powerful flash floods that tore through the region. They constructed a sophisticated system of dams, cisterns, and hidden channels to divert floodwater away from the city while also capturing it for their daily needs. They tamed the desert to carve a metropolis from stone. Imagine sitting in Rome's Colosseum with 50,000 other spectators on a scorching summer day. The Romans had a solution for that. A massive retractable awning, called the velarium, could be extended over the seating area to provide shade. This enormous canvas roof was operated by a team of experienced sailors using a complex system of ropes, pulleys, and masts. It was an architectural feat that provided comfort on a scale never seen before, turning the amphitheater into an all-weather venue. In Turkey, there is a site that predates Stonehenge by 6,000 years. Göbekli Tepe was built by hunter-gatherers before the invention of pottery, writing, or even metal tools. Yet, it features massive T-shaped stone pillars, weighing up to 20 tons, decorated with intricate carvings. How a pre-agricultural society organized the labor and developed the techniques to quarry, transport, and erect these monoliths remains a profound puzzle for archaeologists. Along the Great Wall of China and other ancient structures, builders used a surprisingly effective ingredient to strengthen their mortar: sticky rice. By mixing cooked sticky rice into a standard lime-based mortar, they created an organic-inorganic composite. This mixture was incredibly strong and water-resistant. The amylopectin in the rice acted as a binding agent, creating a mortar so durable that in many places, it has held the stones together more firmly than the stones themselves have weathered. At the Inca fortress of Sacsayhuaman in Peru, the walls display an even more advanced form of interlocking masonry. The massive stones are not just irregular. They are cut into complex polygonal shapes that fit together like a giant jigsaw puzzle. These ziplock stones, with their multiple interlocking faces, provided incredible stability. During an earthquake, the forces are distributed across the entire wall, preventing any single point from failing. The Lighthouse of Alexandria was one of the 7 wonders of the ancient world, and for good reason. Standing over 300 feet tall, its light was said to be visible from 35 miles away. Ancient texts describe its most advanced feature, a system of polished bronze mirrors. During the day, these mirrors would reflect sunlight, and at night, they would amplify the light from a fire. This precision mirror system was a precursor to modern lighthouse technology, a beacon of ancient optical science. Why have some Roman roads lasted for over 2,000 years? Part of the secret lies in a simple but brilliant design feature called crowning. Roads were built with a slightly convex curve, making the center higher than the edges. This curvature allowed rainwater to drain off to the sides into prepared ditches, preventing water from pooling, eroding the surface, and turning the road into a muddy mess. It was a simple solution for longevity that modern road builders still use. In what is now Pakistan, the Indus Valley civilization built one of the world's earliest planned cities, Mohenjo-daro. At its heart was the Great Bath, a large public pool. To make it completely waterproof, engineers lined the tank with tightly fitted bricks laid on edge with gypsum plaster. Then, as a final seal, they applied a thick layer of natural tar, or bitumen. This multi-layered waterproofing was so effective that it could have held water for centuries. The Maya were not only brilliant astronomers but also gifted acoustic engineers. If you stand at the base of the Great Pyramid at Chichen Itza and clap your hands, the echo that returns sounds uncannily like the chirp of the sacred Quetzal bird. This is no accident. The specific height and spacing of the pyramid's stone steps were intentionally designed to create this unique acoustic effect, turning the structure into a giant instrument that connected the people with their gods. Finally, in the hot, arid lands of ancient Persia, people stayed cool without electricity. They used wind towers, or badgers. These ingenious structures would catch the wind high above the building and funnel it down into the rooms below. The movement of air created a pressure difference that would also draw hot air up and out of the building. It was a sophisticated passive air conditioning system that made life in the desert comfortable, powered only by the wind. From self-healing concrete to acoustic pyramids, these ancient engineers were not just builders. They were scientists, artists, and visionaries. Their work stands as a timeless reminder that with enough ingenuity, humans can achieve the extraordinary. What other ancient marvels leave you in awe? Let us know in the comments. Thanks for watching, and if you enjoyed this journey into the past, don't forget to like and subscribe for more.